Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is sequences and series. This is an introductory video. So what is a sequence? The different numbers occurring in any particular sequence are known as terms. The terms of a sequence are denoted by variables a1, a2, a3, an. This is the nth term. If a sequence has finite number of terms, it is known as a finite sequence, and if it is having infinite number of terms, it is known as infinite sequence. For example, the nth term of an AP is given by a plus n minus 1d. A is the first term, n is the nth term, d is the common difference. Let us take one example of a sequence. On 1st January, we deposit 100 rupees in a piggy bank, and each subsequent day we add rupees 20. Then let us see what will be the total money: 100, 120, 140, and so on till 200. So this is a sequence because it is a pattern of ordered list. Now let us form the general term or general form of a sequence. So sequence we have seen is an ordered list of objects. We are given two examples here: 100, 120, 140, 160, 180, 200, 2, 4, 8, 16, 32, 64. We see that between 100 and 120 the difference is 20. Similarly 120 to 140 difference is 20. The first term is denoted by A1, we have seen it earlier, so A1 will be 100, A2 will be 120, A3 will be 140, and so on. Similarly, in this another sequence, A1 will be 2, A2 will be 4, A3 will be 8, and so on. So this is the notation. First term is given by A1, and so on. Fourth term A4, nth term by An. So what will be the general term? We will see in the next slide. So for this particular sequence, A1 100, A2 120, A3 140, we see that 100 can be written as 80 plus 20 into 1. Similarly, A2 can be written as 80 plus 20 into 2. So the general term will be An equal to 80 plus 20n, where n is some integer. Similarly, for this particular sequence, we see that A1 is 2 power 1, this is 2 power 2, this is 2 power 3, and so on. So the nth term will be An equal to 2 power n. Now in this particular case, this particular example, we are given a sequence An equal to 2n plus 3. We need to find the first 5 terms. So how do we find first 5 terms? First term will be n equal to 1. So A1 will be 2 into 1 plus 3, which is 5. A2 will be 2 into 2 plus 3 equal to 7. And fifth term will be A5 equal to 2 into 5 plus 3, which is 13. So we know A1, A2, An is a sequence. So the expression A1 plus A2 plus A3, this is a series associated with this sequence. So we use the word sigma. Sigma, this A1 plus A2 plus A3 plus An can be written as sigma k equal to 1 to n ak. Take example 1, 3, 5, 7. The sum of the series will be 1 plus 3 plus 5 plus 7, which is 16. And it is important to note that when the sequence is finite, we get a finite series. Similarly, when sequence is infinite, we get an infinite series. Now let us find what is geometric progression. This is again a series or a sequence such that the ratio of two consecutive numbers is always a constant. Let us take this example: 1 by 9 minus 1 by 27, 1 by 81. We see that if we multiply 1 by 9 by minus 1 by 3, we get minus 1 by 27. If we multiply this by again minus 1 by 3, we get 1 by 81 and so on. So this R, which is the ratio of the k plus 1th term divided by ak, is always a constant. So if we see minus 1 by 27 by 1 by 9, we see that it is always a constant. Similarly, 4 by 2 or 8 by 4 is always constant. And the series associated with the this particular geometric sequence is called as geometric progression. What is general term of a geometric progression? So A1, A2, An is a geometric sequence. The ratio A2 by A1, A3 by A2 is always a constant. This is called as common ratio. So A1 plus A2 plus An is called the geometric progression. This is the first term. So the general term of a geometric progression is An equal to Ar n minus 1, which is also the last term of the geometric progression. This formula is important. Let us take one example. We need to find the 20th and the nth term of the geometric progression. This particular is the sequence 5 by 2, 5 by 4, 5 by 8. So first we know A is 5 by 2, that is the first term. Let us find the common ratio, which is the 5 by 4 divided by 5 by 2, which is half. So we need to find 20th term, which is A20, and the nth term An. So A20 is AR 20 minus 1. This is the general formula we know. An equal to AR n minus 1. We just put n as 20. So R is half. So we substitute this. A is 5 by 2. We substitute in this equation. So A20 will be 5 by 2 into half power 19. So let us take this, can be written as 1 power 19 divided by 2 power 19. 1 power 19 is 1. So numerator will be 5. Denominator will be 2 into 2 power 19, which is 2 power 20. Similarly, nth term can be written as 5 by 2 into half n minus 1, which is 5 by 2 power n. What is the sum of n terms of a geometric progression? Let us try to understand. If this is a geometric sequence, AR square, AR cube, AR n minus 1, then the sum A plus AR square is a geometric progression. So sum of this will be A plus AR square plus AR cube plus so on until AR n minus 1. The sum is given by, this is the derivation. We are not going through. We'll just find the formula. The sum of the n terms of a geometric progression is given by A into 1 minus Rn divided by 1 minus R. It is important that in this expression R is not equal to 1. What happens if R equal to 1? The denominator becomes 0. So this expression cannot be determined. So this formula is valid when R is not equal to 1. If R equal to 1, we use the formula Sn equal to Na. Let us take one example. How many terms of geometric progression 3, 3 square, 3 cube are needed to give the sum 120? So let us find what is the first term is 3. What is common ratio? R. That will be 3 square by 3, which is 3. So we got A and R. We now use the formula Sn equal to Arn minus 1 by R minus 1. This is equal to 120. We substitute the value of A and R in this. So 3 into 3n minus 1 divided by 3 minus 1 is 120. This is 2. So this will be 240 by 3. 240 by 3 is 80. So 3n minus 1 is 80. 3n is 81. So n will be 4. Now we introduce the term geometric mean. What is geometric mean? If two numbers are given A and B, the geometric mean lies in between and is given by the formula G equal to square root AB. Let us take one example. So geometric mean of two numbers 2 and 32. So we use the formula G Geometric mean equal to square root 2 into 34, which is 8. Let us find what is the average mean or the mean. So that will be 2 plus 32 divided by 2, which is 17. So mean is somewhere in between these two numbers, but geometric mean is much lower than the average or the mean of the two numbers. This is important. Let us try to take another example in which the first and last numbers are given by A and B, and we need to introduce few numbers in between this A and B such that it forms a geometric progression. So the only important thing is how to get these numbers. For example, we want to add three numbers between say 5 and 50. So how do we get those three numbers? If we can get the common ratio, then we can easily find the three numbers. So how do we get the common ratio is given by this formula. So R will be B by A the whole power 1 by n plus 1. This is the formula. So if we get the R, first term can be given as AR, second term will be AR square, and so on. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.